Okay, let's go for chapter 2, chain drive transmission alloy. So this one is gonna be the things that will make a big concern on the major advantage of using roller chains over a belt is that rolling chains do not slip, which is the major parts that what we're gonna go for. Design of the chain drive transmission is mean everything's gonna be constant. Speed ratio, if you don't have slip, things like that, everything's gonna be constant. But of course, right, if we just apply for chain drive transmission system, we're gonna cause some difficulties. Okay, with the things that what we face on is gonna heavy, high horse, things like that. Okay, so therefore this kind of difficulty that what we're gonna get on it anyway. So that's why it's gonna be some kind of the sense of us gonna make some kind of like a selection on the chain drive transmission anyway. Okay, let's go for the change drive transmission components to the type of chains. Okay, typically we're gonna have the roller chain is gonna most commonly change that what we've got. It's gonna be some kind of like the mechanical drive, okay, for the high speed, high power, things like that. It's comprised of four major components. Number one is gonna be the pin on the left hand side. Its corresponding drawing is gonna be look like that. So the pin is going to be the major parts up there. And second is going to be the pairs of the link plates. Okay, we have one at the outer, one on the inside. So therefore, everything's going to fix up together with the pin there. So therefore, the third one is called the butching fixed solidly with the inner plate link. So we apply the butching, okay, to fix it, okay, solidly. It means this one gonna move, the butching is gonna move along with the inner plate here. Okay, and then the fourth one, roller freely moving along the bushing axis. And then we just put the roller, okay, again over, okay, the butch, things like that. And then it's freely loaded, things like that. So that's why this one of roller, of course, it's gonna allow to do some kind of like run over with the sprocket teeth, things like that, the gear teeth, things like that, okay, to do some less friction, whatever. So therefore, we're gonna have some kind of like a mechanical drawing, look like that. Number one, two, and three, and four. Okay, and we have the dimension of B1, B2, B3, and B4 respectively. And then we have D1, the diameters of the butch. Okay, and I'm sorry, D1 is going to be diameters of the roller, and D2 is going to be diameters of the pin respectively. Okay, this one is gonna be some kind of dimensional standard. Another one is gonna be pitch. It's gonna be the distance apart from one pin to another pin, consequently. Okay, and then this type of change can be applied for more strain. Okay, for instance, like number A is gonna double stand. It's been two rows. B is triple stand. It's three rows, and four is gonna be quadruple, four strands, things like that. And then the small gears here, we call it pinion. The bigger gears here, we call it sprocket. Anyway, and we have four strands of chains, things like that, to drive it through. Okay. And then another component on the chains, you're gonna have a cotter pin to just make fixed. Okay, and the rear parts of the pin, we have a hole here, and then we apply the cotter pin inside to lock it properly. And then another lock on the pin here. We have the spring U connectors there. Okay, we have a groove at the end of the pin there, and then we just apply the spring U in there. So if you compare A and B gonna obtain for very high speed, but A is gonna be low speed anyway because net anyways here to just do some damage on the machine components anyway. Okay, and then C is going to be spatial chains connector. This one going to be most likely is for the conveyor chains anyway. Okay, and then for the boot chain, okay, we just do the boot chain is going to be the bigger chain, things like that. We take the loader out. This type of boot chains you're gonna apply a lot with a low speed but high torque, things like that, like the machine component in the sugar mill, sugar factory, things like that. Okay, and then inverted two chains, or sometimes we call it silent chains. So therefore, it typically look like that. Okay, the chains are gonna have a teeth look like that, corresponding to the your teeth, things like that. Okay, so therefore, we apply a lot of context area, things like that, to make it silent, to make it low noise, things like that during the motion. But of course, it's gonna be heavy. Okay, so therefore, the shaft and everything's gonna resist more weight on it. It's gonna make concern on the design in a way. And then special types of chain typically is gonna be a some kind of what we call conveyor chains anyway. We have number A, detachable, easy to take out apart, like that, okay. And then B is gonna have a steel pin, allow the platform to sit on the steel pin here, okay. So that's why it's gonna be quite suitable for applied on the conveyor chains, okay, to do some carry on the weight, whatever. And then another commonly we're going to sprocket, okay. Sprocket we're going to have a very similar to the pin and things like that, okay. For instance, the P term is called a pitch or circular pitch, and alpha going to be called the pitch angle, and then these have a addendum circle, addendum diameter, and D is going to pitch diameter. These have F is going to be dedendum diameter respectively. Okay, so this one is gonna be the definition terms basically for the chain style transmission systems in a way.